Alright, so right now we're going to look at average velocity and instantaneous velocity. So before we get velocity, let's talk about speed. Average speed is the total distance divided by time elapsed. Now speed is a scalar, which means it has a magnitude but no direction. So speed is always positive. Velocity is a vector because it shows both speed, which is a scalar, but it becomes a vector as soon as you give it a direction. And that's where that positive and negative comes in. So average velocity is displacement over time. We also could look at it as final minus initial position, like we talked about previously, divided by the time that's going by, or time elapsed. Now elapsed time is time we end versus minus time we start. It doesn't have to necessarily be 0. We like it to be. It makes the math easy, but it doesn't have to be. So really, velocity is delta x over delta t by definition, using our definition of displacement and time elapsed. Here's an example. So we got a runner, and it's on the x-axis, starting at 50 meters from the origin, traveling to the left or the negative direction to go to 30.5, as we can see in this figure. What was the runner's average velocity? So velocity, change in x over change in t. Our change in x is our final x, 30.5, minus our initial, 50.0, divided by the time elapsed, which is 3 seconds. Everything else here is just number crunching. So on our calculator, we take 30.5 minus 50 and get negative 19.5. We divide that by 3. So we get negative 6.50 meters per second for our average velocity. How far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 16 or 18 kilometers per hour? So velocity, change in position over change in time. How far would be our change in position? We can solve this in terms of change in position, and we can also use it like this and cross multiply. I'll show you this way, because that's the way I usually do it in my head. So I got 18 over 1 is our velocity. We don't know our change in position, but we know our change in time is 2.5 hours. So change in x is going to be 18 times 2.5. So you math whizzes in your head probably have this down already, but I'm going to type it in so my sig figs are right. And I get 45 kilometers as my distance traveled. So just manipulate this equation to solve for whatever you need to. Another term that comes up is instantaneous velocity. So that's the average velocity during a very small time period. So let's say, for instance, we do some math and we find our average velocity to be 30 kilometers per hour. But we know that anytime we travel, it's going to be stop and go, speed up, slow down, etc. And so we have to look at the whole thing. And instantaneous would be, what is our speed here, right? What is our velocity at this point? What is our velocity at this point? That's instantaneous. Average, again, is just all of them put together.